Logic gates. Logic gates are digital circuits capable of performing a particular logic function by operating on a number of binary inputs, which means logic gates perform a particular logic function based on the given inputs, and these inputs are binary inputs, which means zeros and ones. When we give zeros and ones as input, these logic gates perform a logic operation and they will give us an output. This is a basic concept of logic gates. Logic gates are the basic building blocks. They are the basics of many digital circuits. Nowadays we are seeing a lot of IoT devices, and in that also the basic building blocks are these logic gates. Next, let's see the type. Logic gates can be classified as follows: basic logic gates, universal logic gates, and other logic gates. And again, basic logic gates are classified as AND gate, NOT gate, and OR gate. Universal logic gates are classified as NAND gate and NOR gate. Other logic gates are XOR gate, XNOR gate. Logic gates, as we discussed, these are the fundamental logic gates. Universal logic gates and other logic gates are also constructed using these basic logic gates, and these basic logic gates consist of AND gate, OR gate, and NOT gate. This is a logic symbol of AND gate. See, here we take A and B as input, and this is a logic symbol of AND, which is like D in English alphabets, and we get an output as Y. This is called output line. Here in AND gate, if the both inputs are 1 and 1, in this case A is equals to 1, B is equals to 1, then only we get the input as 1. Otherwise, output as 1. Otherwise, the output will be 0. See, we can understand that using this truth table. See, here if the A and B are 0, 0, the output is 0. If the inputs are 0 and 1, the output is 0. If the inputs are 1 and 0, the output is 0. Only if the inputs are 1 and 1, we get the input as 1. Here, coming to timing diagram, see, here we draw this diagram based on our inputs and our output. See, when in time period t1, the input is for A is 0, for B is also 0, and we get output also 0. Similarly, in time period t2, A is 0 and B is 1. See, based on those, we write what is the output. We draw it here beside to Y. This logic symbol of OR gate, where we have A and B as our inputs, and this symbol is the logic symbol of OR gate, and here comes the output line Y. Here Y is equals to A or B. Here we use plus as OR symbol. Plus is OR symbol and dot is AND symbol. The truth table of OR gates. See, in OR gate, when at least one is there in input, we get the output as 1. See, in first case we have 0, 0, so output will be 0. In second case we have 1, 1, means we have at least 1, 1, so the output is 1. In third case also we have binary digit 1 in our input, so the output is 1. In fourth case, the two inputs are 1 and 1, so the output is obviously 1. This is the timing diagram of OR gate, which is very much similar to the AND gate. Here also we draw the inputs, and below that we draw the output based on the time periods t1, t2, t3 and t4. Next, coming to NOT gate. See, NOT gate symbol is like a triangle and a bubble. If input is A, the output is A bar, which means opposite. See, if this is a truth table of NOT gate. If the input is 0, the output will be 1. If the input is 1, then the output will be 0. The timing diagram of NOT gate. See, in the time period t1, A is 0, then output will be A bar, that is 1. In time period t2, A is equals to 1, then the output will be 0.